सेटिंग देखिए बेटा, ग्राफ ऑफ टेम्परेचर वर्सेस हीट, graph of your temperature versus your heat. Okay. As I told you better yesterday, अगर अपने पास कोई ice है right now for me, if it is converting from minus, okay, so from minus it will try to go first initially to which state beta? Minus of, like say, example, I'm having then ice. Yesterday I told you ice at your minus 20 degrees Celsius. Journey of ice, did I told you yesterday? Yeah. So देखिए minus 20 degrees Celsius of ice will convert into ice at your 0 degrees Celsius. And 0 degrees Celsius of ice is converting into water at 0 degrees Celsius. तो स्टेट क्या है यहाँ पर बेटा? स्टिल सॉलिड ही है ना, isn't it? Then from ice to water, liquid, water to water, liquid, water to steam, condensation or vaporization. So if I need to draw the graph for that one, देखिए बेटा, तो first when it is at minus 40 degrees Celsius, minus 40 degrees Celsius या 20 degrees Celsius, it will convert into ice at 0 degree Celsius. यहाँ पर 0 degree Celsius होगा बेटा, it is converting into ice at 0 degree Celsius. Okay, then from 0 degree Celsius of ice it will convert into 0 degree Celsius of water, isn't it? तो यहाँ से यहाँ तक Q1 हो गया, फिर यहाँ से यहाँ तक this will be equal to Q2. Then water, then this is right now for me your water at 0 degree Celsius. This is your ice at 0 degree Celsius. Then from there, water at 0 degree Celsius will convert into your water at your 100 degree Celsius. This is your 100 degree Celsius. On y-axis, you are taking your temperature in degree Celsius. On x-axis, you are taking the heat, change in your energy. Okay. Then from water at 100 degrees Celsius will convert into your steam. It will convert into the steam at what temperature again? 100 degrees Celsius. Then steam at 100 degrees Celsius will convert into the vapor at your 100 degrees Celsius. Isn't it? So it is Q1, Q2, here it is your Q3, and this will be equal to your Q4. Am I clear? Now he may ask you, how do you calculate the slope? So slope of this one will always gives me 1 by m into your specific heat of your ice. Because we know the formula delta Q is equals to m into S into your delta T. So it is delta T divided by your delta Q. Delta T is your temperature, na beta? So that will be equal to m into your S. So slope of this one is giving me for me 1 by mass into your specific heat. Am I clear? The specific heat of your ice. Now if I talk about here beta, slope here will be equal to your 1 by mass will remain for me same, but here it is a specific heat of your steam or it will be your vapor. Clear? Am I clear with this one? Am I clear beta? Graph of your temperature versus your heat. Slope of this one will always give me 1 by mass into specific heat. Minus 20 से लेके 0.27 it was 0 degree Celsius of ice. It is giving the specific heat of ice. Then from 100 degree Celsius of water to your 100 degree Celsius of your steam, it is converting into your vapor. Am I clear? ये 100 के ऊपर भी हो सकता है बेटा. This graph जो ले रहे हैं, this temperature may be like say 110 degree Celsius ऐसा कुछ higher होगा. Steam is converting into, again here also steam, but at higher temperature of 110 degrees Celsius. कुछ ले रहा हूँ मैं रफली बेसिकली आपको समझाने. Okay. So the next one and very important concept, method of mixtures. Method of mixtures. Okay. Type 1 type of problem set. Question लिखो. Let's say if I'm having 10 gram of ice at minus 20 degrees Celsius is mixed with is mixed with 40 gram of water. 40 gram of water at 50 degrees Celsius. Find final temperature. Find final temperature of mixture. Anyone? 10 grams of ice at minus degrees Celsius, minus 20 degrees Celsius is being mixed with 40 grams of water at your 50 degrees Celsius. Okay, find the final temperature of the mixture. Who will lose and who will gain beta? 10 gram of ice at minus 20 degrees Celsius is mixed with 40 grams of water at 50 degrees Celsius. Obviously, 40 grams of water will lose and 10 gram of ice at minus 20 degrees Celsius will absorb. Isn't it? Like say if I'm talking about first one is cold. Cold body will absorb, isn't it? Minus 20 degrees Celsius will be converting into first 0 degrees Celsius of your ice. Am I clear? So what will be the Q released here? Q is equals to your mass is 20, specific heat of ice is half, into temperature difference will be equal to 20. So amount of energy required to convert minus 20 degrees Celsius of ice to 0 degrees Celsius of ice is, it is roughly 200 calories. 2 ones, this is your 2 tons. Am I clear? Zero. Next step, 0 degrees Celsius of your ice will convert into 0 degrees Celsius of water now beta. What is amount of energy required here? Q is equals to M into L of your ice. So mass is how much for me? 20. Latent heat of ice is 80. So it will be equal to 8 to the 16. 1600 calorie. Okay. I'm bringing the system to 0 degrees Celsius of water. In the same way, if I'm talking about hot bodies, hot body will be releasing the energy, isn't it? So how much amount of gram beta? Water at your 50 degrees Celsius. Water at your 50 degrees Celsius needs to convert into 0 degrees Celsius of your water. Isn't it? Both of them are water. So what is the amount of energy required here? Q is equals to M into S into delta T. Mass is how much for me? 40. Specific heat of water is 1. Temperature difference is how much better? 50 to 0. Final temperature is 0. Initial temperature is right now for me 50. Higher minus lower. So it will be equal to 50 degrees Celsius. So obviously it will be equal to your how much for me? 2000 calories. Am I clear? So first we need to bring the total system to one common temperature beta. Am I clear? All right here. Bring the system to one common temperature. One common temperature. Here I brought it to 0 degrees Celsius of water. Okay. Ice at minus 20 degrees Celsius is converting into 0 degrees Celsius of ice. Then ice at 0 degrees Celsius is being converting into your 0 degrees Celsius of your water. Am I clear? Then I calculated what is the amount of the heat required to convert the water at 50 degrees Celsius to water at 0 degrees Celsius. So I got the amount of your energy for the given process. Now tell me how much amount of energy is being released or left out. How do you calculate that one? Energy released Q left will be equal to Q release minus Q absorb. So it is how much right now for me? 2000 minus, it is 1600 plus 200. It will be equal to your 1600 plus of your 200 calories. So obviously it will be equal to how much for me? 2000 minus of your 1800. That means it will be your 200 calories. This much amount of the energy is being released. Am I clear? Any doubt in this one? Now see, what should be your answer? Now you should be telling that, sir, when you're converting 10 gram of ice at minus 20 degrees Celsius and 40 grams of your ice at 50 degrees Celsius to the 0 degrees Celsius of your water, then total composition must be equal to how much for me? Total composition, total composition at 0 degrees Celsius is how much better? 20 gram of ice at 0 degrees Celsius plus 40 gram of your water at 0 degrees Celsius. And 20 gram of ice is also converted into your water, no? So it is a 20 grams of your water at 0 degrees Celsius. That means 20 plus 40, that must be your final composition, isn't it? Your answer must be equal to how much for me? 60 grams of your water. Am I clear? But when both of them are left or both of them are being mixed, when, but I'll write here, but when both are mixed, some amount of energy is left. Some amount of energy is left. What is that amount of energy left? Q left is equals to how much for me? 200 calories of energy still is there. So how do you calculate that Q left? Q left will be equal to M into specific heat of water into temperature difference. Q left is how much for me? 200. That is equals to your total composition is right now for me 60. Specific heat of water is 1 into temperature difference delta T. Okay. So now what is the temperature at that? So delta T is equals to how much for me? 200 divided by your 60. So that will be equal to your 2 3 z 2 10 z. That is 10 divided by 3. That is equals to 3.33 degrees Celsius. This will be the temperature. Okay. Am I clear? So right here, the answer for mixture problems must be that means temperature delta T must be in between 0 degrees Celsius and 100 degrees Celsius. Then complete ice or steam is said to be completed. Is said to be completed. Am I clear? So what your answer should be there? Whenever you are mixing water and ice or steam, your answer must be in between. Temperature must be in between 0 and 100 degrees Celsius. Then both of them might have been converted into the water. Then total composition, you will say that it is 60 grams of your water. So you need to check whether the temperature is in between 0 to 100 or not. If it is not in 100, beyond 100 or lesser than 100, it means that certain amount of your steam and certain amount of ice is being left out. Okay. One more point. If temperature delta T is below 0 degrees Celsius, then we must understand that some ice is left in water. Like say you might have been seen that when you go for movies like in PVR or anywhere, you get a cold drink in which ice has been mixed. isn't it? Even though you complete your complete cool drink, the ice will be not melting in that one. That means even though when you're mixing the ice in the water or in the coke, still certain amount of ice has been left out because the temperature of that water was lesser than 0 degrees Celsius. That is the reason complete ice has been not melted. At that time, we are having a mixture of your ice and water. So how do we check that one? We need to check with the temperature. If the temperature is below 0 degrees Celsius, then we must understand that some amount of some ice has been left in water. Similarly, if temperature temperature delta T is delta T is above 100 degrees Celsius, then we must understand that some steam is left in water. Left in water. We need to calculate how much amount of steam is there. Then that will give me the composition type of your problems. Am I clear? See here I got the answer in between 0 and 100. So total composition is what means? What will tell me the answer for this one? So total composition is 60 grams of your water. Okay, sure. Type 2 problems. Now see the terminology of this question, beta. If I say that if 40 gram of your ice at minus 20 degrees Celsius is mixed with 40 grams of water 40 grams of water at 60 degrees Celsius. Okay, then find its composition. Find its composition. Am I clear? Sure. See this one. First, you write right now for me the cold. Cold will absorb. So what is happening here? How much? Minus 20 degrees Celsius is coming to your 0 degrees Celsius of your ice. So what is the amount of energy required here, beta? Q is equals to M into specific heat of ice into temperature difference. So how much amount of mass I told you, beta? 40. Specific heat of ice is half into temperature is right now for me 20. 2 ones, this is 2 tons. This will be equal to how much for me, beta? 400 calorie. Okay. Then again, ice at 0 degrees Celsius. Ice at 0 degrees Celsius will convert into water at your 0 degrees Celsius. So Q will be equal to M into L of your ice. So it is 40 into your 80. This will be equal to your how much will be? How much? 3200 calories. It's very huge now. See, it is converting ice at minus 20 degrees Celsius to 0 degrees Celsius. I just need 400 calories. But to convert the ice at 0 degrees Celsius to water at 0 degrees Celsius, I need the amount of energy 3200 calories. Okay. The same way, if I'm talking about your hot body will what it will do, beta? It will release how much amount of water we are adding here? Can anyone tell me? 40 grams of water. So it is 40 grams of your water 40 grams of your water at 60 degrees Celsius. 40 grams of your water at what temperature? At 60 degrees Celsius. Yeah. 40 grams of your water to be converted into your 40 grams of water at 0 degrees Celsius, isn't it? So 40 grams of water at what temperature? This is 60 degrees Celsius. What is the amount of energy required? Beta, can you tell me? Q is equals to, here is the temperature difference, M into S into your delta T. Mass is right now for me 40 grams. Specific heat of water is 1. Temperature difference is right now for me 60, isn't it? 6 4s are 24. So it is 2400 calorie. Am I clear? Are you able to follow better? समझ में आ रहा है?
Yes, sir.
Am I done with this one? First process is I took the cold, next process I took the hot, and I'm bringing the total system to one common temperature, that is 0 degrees Celsius of your ice. So I got the energy in both the cases. Now tell me how much amount of energy has been left out. Q left will be equal to Q released minus Q observed. How much is Q released, beta? 2400, isn't it? Q released is only 2400, but Q observed is 3200 plus 400 minus 3600. See how much I'm getting? You'll be getting the answer in terms of negative. Q released is 2400 and this is minus of your 3200. This 3600. How much it is? Minus 1200 calorie. So we're getting the answer in terms of what? Negative. So whenever we get the answer in terms of negative, it should be understand that certain amount of ice is left. Okay, I'll write one point here. Since Q released is lesser than Q observed. Okay, therefore, complete conversion of ice into water is not possible. Into water is not possible. Some amount of ice will be left in water. Okay, so let's see how much amount of ice has been left. So let X grams of your ice get converts into your X gram of your water. Okay, so Q left will be equal to your X of your ice, which is left, into L of your ice. Q left is equals to how much, beta? How much is Q left there right now for me?
Minus 1200.
1200. So it is 1200 is equals to X of your ice into latent heat of ice is how much? 80. So X is equals to 120 divided by 8. Am I clear? So how much I'm getting, beta? 15 gram of your ice is left. Okay. But tell me what will be the conversion, beta? Tell me the final concentration. Ice was how much for me? 40. In that one, 15 is been not left. So it will be equal to how much? 25 gram of ice is been converted. Okay. Now what is the composition, beta? Composition or mixture is equals to 25 grams of your ice out of 40 grams plus water is totally converted. How much it is right now for me? 40 grams of your ice. Oh, water, sorry. So it will be equal to how much for me? 65. This is 40 grams of your water. So 20 grams of ice is converted into water. So I will write it, it will be better. It is your 20 grams is been converted. 20 grams of your water. How much ice is converted? Better 25 grams of your ice is converted into water. So it is 25 plus of your 40. So it will be 65 grams of your water. That will be the answer. Am I clear? Sorry, it is 15 grams. No, what 25 I'm writing. 40 minus, yeah, this is correct. Am I clear? Any doubt in this one? See, whenever you get the answer in terms of your negative, it should be understand that certain amount of ice has been left out, isn't it? So how do you calculate that amount of left out ice? So 15 grams of ice has been left out, isn't it? You don't write this point, otherwise you'll get confused. So Q left will be equal to X of your ice into latent heat of your ice. So 15 grams of ice is been left out. Is been 15 grams of ice is been left out. Out of how much grams, beta? 40 grams. So 40 minus 15, you remove it, you'll get 25 grams of your ice, which has been converted into your water. So the final composition will be 25 grams of your ice, which has been converted into water, plus 40 grams of water. So it is 65 grams of your water. Am I clear? Any doubt in this one? The mixture problem clear है सभी को? So whenever you are doing the mixture problems, beta, it should be understand that your answer must be in between 0 to your 100, I told you. If your answer is below 0 degrees Celsius, certain amount of ice is left. If your answer is above 100 degrees Celsius, then certain amount of steam is been left. Now in this problem, you see, if 40 grams of ice at minus 20 degrees Celsius is mixed with 40 grams of water at 60 degrees Celsius, Then what is the final composition? When ice is converting into water at 0 degrees Celsius beta, it needs a total energy of 3600. In the same way, 40 grams of water at 60 degrees Celsius, when it has been converting into 40 grams of water at 0 degrees Celsius, it just needs 2400 calories. So you try to find out the Q left. Q left is equals to Q released minus Q observed. Q released how much? Q left how much I'm getting? Minus 1200. I told you that your Q released is lesser than Q observed. That means complete conversion of ice is not into water. Complete conversion of ice into water is not possible. So certain amount of ice will be left out in water. In that case, how will do better? Certain amount of ice has been left out means how much amount of ice has been left out. Let's say Q left is equals to X of your left into your L of your ice. So how much amount of ice has been left as water better? 15 grams. So out of 40, 15 grams is being not converted into water. So how much is being converted better? 25 grams of ice. Isn't it? So total composition will be 25 grams of water plus 40 grams of your water. That is 65 grams of your water. Am I clear? Am I clear, better?
Yes, sir.
So these are the two types of your problems in which you need to take care in the mixture problems. Better. So in the thermometry or in calorimetry, we just defined some of the basic definitions. What do you mean by the specific heat? What do you mean by the thermal capacity? So this is your specific heat, then thermal capacity and heat capacity. This all we have defined in the basic values of this one. Done? Sure. I hope you're clear with this one, everyone. Sure. Next one is thermal expansion of solids. Better. Sure. Thermal expansion of solids. See, whenever a solid is being heated, we'll see the expansion in length, breadth, and as well as of your height. That means there is increase linearly, aerially, and as well as of your cubically. Okay, first point. When a solid is heated, there is linear expansion. There is linear expansion, one dimension, comma, aerial expansion, aerial expansion, that is your two dimension, and volume expansion. And volume expansion, that is your three dimension. Okay, linear expansion means rod, aerial expansion means disc, volume expansion means sphere, three dimension board. Okay, so can I say that overall the size of the object increases? This point is very important here. In the bracket you write photographic expansion. Photographic expansion. Okay, so whenever a solid is being heated, you see the expansion in your linear expansion, aerial expansion, and volume expansion. Okay, Like say example, there is a body like this. If temperature is increased, you see, the total plate will increase like this. The two holes will also increase like this. And the body's object, this will also increase. And this one is also increase. Am I clear? Am I clear? Like say, one more example. If there is a body like this, and if there is a small cavity in this one, this is totally like so for solid. And this is your cavity, isn't it? If temperature increases for this one, then overall plate will increase like this, and cavity will also increase in this one. So this will be the given condition. Am I clear? So what you understood by this? If a solid is being heated, we see the expansion everywhere. Like say for example, one more example I'm giving you. I'm having an hollow body like this, inner radius R1 and outer radius R2. So if temperature increases, what is happening? Everything is increasing in this orbital. This is your R1, this is your R2. So in this one, inner radius is increasing, outer radius is also increasing. Difference between them, R2 minus R1 is also increasing. Am I clear? So whenever a solid is being heated, we need to understand like if a photographic zoom, like say if we take a photo in a mobile and try to zoom it, in that one, each and every point will be expanding in that one, the same way like this. Okay. Am I clear? First point. So whenever a solid or maybe a solid body is being heated, we see the expansion in all the dimensions, length, area, and as well as of your volume. Okay, sure. Let us try to go for the first one in this one. What do you mean by linear expansion? First one is linear coefficient of thermal expansion. Linear means lengthwise width. Linear coefficient of your thermal expansion represented by alpha. So it is defined as it is defined as percentage change in length per unit change in temperature. Unit change in temperature. Okay. So alpha is given by that means whenever you heat a body, expansion is directly proportional to the original length. So I'll write the formula for this one here. Alpha is equals to alpha is equals to change in length divided by original length into temperature difference, delta T. Okay. So this is your definition of your coefficient of linear expansion, or the first formula in this one. So alpha is known as coefficient of linear expansion. Delta L means I can write here change in your length divided by original length into your rise in temperature is known as of your alpha. Clear? So alpha is equals to change in length divided by original length multiplied by rise in your temperature partition. So alpha is equals to change in length divided by original length into delta T. Or in words, if I'm writing, alpha is equals to change in length divided by original length into your rise in temperature. Okay. So how do you write the rise in temperature? Delta L will be equal to your how much for me? Let's say if this is your rod, its initial length is L. At what temperature? 0 degrees Celsius. If I heat this body to certain temperature right now for me, now it has been heated to some T degrees Celsius. Then you see that there is an expansion in the rod. So this will be equal to delta L, isn't it? This is your original length is L naught. This is your final length. So delta L will means what I can write? L minus L naught, isn't it? L naught is your original length, isn't it? So can I write here delta L will be equal to alpha into L into delta T, L naught into delta T. Delta L is how much for me? L minus L naught is equals to alpha into L naught into delta T. So what is an expansion in the rod means? What do you write? This L will be equal to L naught plus alpha into L naught into delta T. So if I take L naught to be common, it is 1 plus alpha into your rise in temperature. This is your final increase in the length. Am I clear? So L is equals to L naught into 1 plus alpha into delta T. L naught is your original length, alpha is the coefficient of linear expansion, and delta T is your rise in temperature. Am I clear?
Yes, sir.
Sure. And this is very important, beta. If expansion of a body is same in all directions, such type of bodies are called as isotropic bodies. Okay, that means expansion in x-axis is equals to expansion in y-axis is equals to expansion in z-axis. That is totally is equals to your alpha. Am I clear? The expansion of the body is same in all directions. Such type of a bodies are called as what for me? Isotropic bodies. Okay, the same way. If expansion is different, if expansion of a body is different in all directions or some directions, then such type of bodies are called anisotropic substances, or called as anisotropic substances. That means linear expansion in x-axis is not equal to linear expansion along y-axis, but linear expansion along your y-axis is equals to your expansion in the z. Or alpha x is equals to alpha y, but alpha y is not equal to alpha z. Okay. Or else I can say that alpha x is not equal to alpha y, and alpha y is also not equal to alpha z. Am I clear?
Yes,
If
sir.
is different in all the directions. In first case, you see expansion in x-axis and y-axis is not same, but in y and z it is same. In second case, expansion in x and y is same, but expansion in z-axis is not same. In third case, expansion in all the directions are different. Clear? Sure. Next one is areal expansion. Two-dimension bodies represented by your beta, coefficient of your areal expansion. So for this also same condition, beta, instead of length, you write right now here as area. Beta is equals to delta A divided by A into your delta T. That is nothing but rise or change, I can say. Change in area divided by original area into rise in temperature. Okay, beta is known as coefficient of areal expansion. It is known as what? Coefficient of your areal expansion. Okay, So formula for this one, how much I'm getting? Beta is equals to delta A divided by A into your delta T. That means delta A will be equal to beta into A into delta T. Delta A means what beta? Final area minus initial area. That is your A final minus of A initial is equals to beta. A also I'm writing as A initial into delta T. So final increase in area will be equal to A initial into 1 plus beta into your delta T. So this is the final increase in your area. Am I clear? Remember one formula here, beta. Beta is always equals to your 2 times of your alpha. I'm not going for derivation here. Or in some cases, I can even write beta is equals to alpha x plus of your alpha y. This is for your anisotropic substance. For anisotropic substances, this one, and this is for your isotropic substances. So 99.9% this will be used generally. Okay. So what is the beta value? Beta is equals to 2 times of your alpha. Okay. An increase in area will be equal to your initial area into 1 plus beta into your delta t. Am I clear? Then for one dimension bodies, final increase in the length is L is equals to L naught into 1 plus alpha into delta t. We got two terms, isotropic, and another one is here, anisotropic. Okay, next one. We see expansion in volume, third one, volume expansion. Volume expansion, isn't it? That is represented by gamma, coefficient of your, sorry. So gamma is equals to change in volume divided by original volume into temperature difference. So I can write here change in volume, change in volume divided by original volume, original volume into rise in temperature. Okay. So this is the value of your gamma. So change in volume is what you write. Delta V is equals to gamma into V into your delta T. So it is V final minus V initial is equals to gamma into V initial into delta T. So if I take V initial on the other side and simplify, we get final increase in volume will be equal to initial increase into 1 plus gamma into your delta T. So this is the final increase in your volume. Clear? Let's see. We get one more formula in this one. Gamma is equals to 3 times of your alpha for isotropic substances. Or gamma is equals to alpha x plus alpha y plus alpha z for anisotropic substances. Okay, for isotropic substances, this one. So therefore, I can write alpha is to beta is to gamma is equals to 1 is to 2 is to 3. So relation between alpha, beta, and gamma is how much for me? 1 is to 2 is to 3. Beta is equals to how much I told you? 2 times of alpha. Or alpha is equals to beta divided by 2. Same way, gamma is equals to 3 times of alpha. Or alpha is equals to gamma divided by your 3 times of your alpha. Gamma is equals to alpha is equals to gamma divided by your 3. Am I clear? From this 2 I can write beta divided by 2 will also be equal to gamma divided by 3. So beta will be equal to how much for me? 2 gamma divided by 3. If gamma is given in the problem, is asking the beta, isn't it? Or I can say that gamma will be equal to your gamma will be equal to 3 times of your beta divided by your 2. So these are the some of the relations you need to remember for doing the numericals. Am I clear, beta? Any doubt in this one? टाइम ज्यादा हो गया बस आज So we'll try to complete the expansion of solids in tomorrow's session of a class, and very important topic, Veda. A lot of applications are there, so theoretical understanding is very much important for doing this topic. Okay, sure. All of you, are you able to follow it? I'm having a little bit of cough. I don't. Okay. Sure. We'll try to meet again tomorrow and start doing the problems on this topic. Okay. And applications also. Take care, beta. Bye.